Perfect. So we can start now. Yeah. So again, guys. So this is section 2.3, right? Again, it's about graphing polynomials. Okay. Good morning, Baba. Yeah, so let me just remind you very quickly, I mean, what we did on Monday. First, let me remind you the definition of polynomial. A polynomial, a polynomial is a function f of x of the form. So we said basically, so the idea is that the polynomial is a combination of the powers of x, but the powers that they must be, positive, whole numbers. So of the form, so f of x. So we have powers of x. So we have x to the power n, and of course there's a number, some number in front of x to the power n. Right, and then of course the next power would be n minus 1. So you decrease the power by 1, etc. And there's a number in front of x to the power n minus 1, etc. Right? And then we said the highest power of x, the n, is called actually the degree, right? So the degree n, the degree that's the highest power of x, right? And so that's our n. All right, and the number in front of x to the power n, this a index n, it's called the leading coefficient, right? So the a index n is called the leading coefficient, right? So just to remind you quickly, look, so for example, so let's say you have f of x equals to, let's say you have -3 x to the power 7 minus x to the power 6 plus x to the power 4, for example, minus 2. All right. So then our n, that's the highest power of x, that would be 7. Right, so n is 7, and then so n would be this number 7 here, and our leading coefficient a subscript n, though that will be this -3 here. Okay, so a subscript n, that will be the -3. Anyway, so that's just to remind you the definition of polynomial. Now, after we said. So we want to graph, so our goal was to, graph polynomials, right? So our goal is to graph polynomials, right? And so first piece of information we're going to use is the behavior at infinity, right? So we studied the behavior at infinity of polynomials. So first, we have the behavior at infinity, right? And so we had a table. So just to remind you the table, because we're gonna use it later, to graph polynomials. So just to remind you, what was the table? So we had 4 cases. So the first column, that's when the degree is even, degree n, of course, even. Second column, degree n is odd. Right. Now, first row, that's when the leading coefficient a index subscript n is positive. And the second row, that's when the leading coefficient is negative. Right? And we said, so if you want to graph a polynomial, So then the behavior at infinity, of course, depends on the degree and on the sign of the leading coefficient, right? So when the degree is even and the leading coefficient is positive, so we said then at infinity, the graph would look like this. When degree n is even and leading coefficient is negative, then here will be our graph. When degree n is odd and the leading coefficient is positive, then we're going to be here at positive infinity and here at negative infinity. And in the last case, degree n is odd and leading coefficient is negative, we're going to be in, we're going to have the following situation here. All right. Anyway, so just to remind you of the table, because we're going to use it later, to graph the polynomials. Now, next, so after the behavior at infinity, we're going to use the multiplicity of the zeros or the roots or the x-intercepts of the polynomials. So next piece of information we're going to use is the multiplicities of the roots, zeros, or the x-intercepts of the polynomial of f of x. Right? So let me just quickly remind you. So what do I mean by roots or zeros or x-intercept? So again, that's just x-intercept. That's just the intersection of the graph with the x-axis, right? Now the roots or zeros, that's the solutions. Or x-intercepts. So those are solutions of f of x equal to 0. So roots, when I say roots or zeros or x-intercepts. So, okay, so they are just equivalent, equivalent names. So they are just solutions of f of x equal to 0. Right? Now, and then we define the multiplicity of roots or zeros or x-intercepts. So definition. So we said the multiplicity of a root or a zero of a root is actually the number of times okay, the root is a solution of f of x, is a solution of f of x equal to 0, right? Now, so the question now, how do we find the multiplicity of the roots? Okay, so now we're gonna try to answer the following question. So how do we find, okay, so how do we find the multiplicity of the roots? Multiplicity of the roots. Okay, so I guess that's where we stopped on Monday. Probably we had one example. I think we had just one example, but I mean, let me explain again how we find the multiplicity of the roots. So to find the multiplicity of the roots, there are 2 steps. Okay, so the step one, you have to solve f of x equal to 0 to find the roots. Okay, so first you have to find the roots. Right? And in the second step, step 2, because there are different ways actually to solve f of x equal to 0. You can use, it depends. You can factor, you can use quadratic formula if you have a quadratic function, etc. But in the step 2, you have to factor here. In the step 2, you have to factor factor f of x. We have to factor f of x. All right, so those are the steps if you want to find the multiplicity of the roots, right? First, solve f of x equal to 0. Sometimes when you're gonna solve f of x equal to 0, you're gonna factor. But anyway, the step 2, you are required to factor f of x, okay, to find the roots, to find the multiplicities, right? So here to find, so factor f of x to find the multiplicities. Right? Okay, so now let me show you an example. Example 1. All right, so let's say you have f of x equals to minus 2x to the power 5 plus. Yes.
Professor, do you think you can just actually go over like the first exercise from Monday, because there was like a little part that I was confused with, like I wasn't too sure.
Yeah, sure. Actually, I don't remember what was the equation.
It was f of x equals to x to the third plus 4x squared plus 4x.
Plus 4x. Okay. Yeah, sure, we can do that. Okay. Let's do that first then. Okay. So we said x, so x to the third plus 4x squared plus 4x, right?
Yeah.
All right. So I want to find, so the question here is to find the roots and their multiplicities, right? And their multiplicities. Okay, so that's the question, right? So first step 1, we said we have to solve f of x to find the roots. So let's solve f of x. So step 1, we have to solve f of x equal to 0. So that will be, of course, x cubed plus 4x squared plus 4x equals to 0, right? Now, so first remark, guys, because it's x cubed, right? X third. So the highest power, of course, here is 3, right? The degree of this polynomial is 3, right? So because the degree is the highest power of x here is 3, or the degree is 3, then we expect 3 solutions. So we expect to have 3 solutions. Okay. So if you have a polynomial, let's say of the degree 10, like x to the power 10 plus x to the power 8, etc., right? So then you expect actually 10 solutions, right? Because the highest power of x is 10. So here in this case we have x cubed, so 3 is the highest power, so we expect 3 solutions. Now, of course, here it's x cubed, so we cannot really use the quadratic formula, right? Quadratic formula is for quadratic functions when the highest power of x is 2. Here, the highest power of x is 3. So we cannot use the quadratic formula, of course. Okay, so cannot use quadratic formula. Okay. Okay, so if I cannot use quadratic formula, what will be the next thing I have to try to do? So we can try to factor, right? So we need to try. So we need to factor, right? So factor f of x. Right? So can we factor f of x? So let's see. So when you factor f of x, it means that you need to find for a common factor, right? So you need to find here. We need to find a common factor. All right. So if you take a look to the function f of x, so we have x cubed, we have x squared, and we have x, right? So I mean, a common factor here would be obviously x, right? So x is a common factor. So we can x is a common factor. All right, so then we're going to factor out x. So here's my x. So we have x cubed, so we have to multiply this x by x squared, right? Because we have x cubed here, right? So x times x squared, that would be x cubed. Then we're going to have plus, there's 4, so here's my 4. There's x squared, so I need to multiply x by x, right? So that's 4 plus 4x. And then here, of course, there's 4 times x. So if you pull out the x, then you are left with 4. So here it's plus 4, right? That's equal actually to 0. All right. So it's x times x squared plus 4x plus 4 equals to 0. Right. Now, so I have my first factor. So this is so I have this x here times this x squared plus 4x plus 4, right? And again, guys, I wanna solve f of x equal to 0. So what's the point? So why do we factor? We factor because we're gonna have a product, and when you have a product equal to 0, it means that one of the numbers is 0, right? So because I have a product now, you see I have a multiplication here, right, which is equal to 0, then either this x here is 0 or the second number here is 0. The x squared plus 4x plus 4 is 0. Okay, that's why we factor, right? So so then x is 0, or of course the x squared plus 4x plus 4 is 0. Okay, well, so I got actually my first solution, right? I got my x equal to 0. That's my first solution, right? Now, what about the x squared plus 4x plus 4 equal to 0? So I have to solve this equation here, this one here. Well, I mean, this is just, it's a quadratic equation, right? We have the highest power of x is 2, so we can use a quadratic formula, right? So here I can use my quadratic formula. So my x would be minus b, so the negative 4 plus or minus square root of b squared minus 4 times a times c over 2a, right? So then my x, so my x is negative 4 plus or minus. So that's 16. Sorry, here the c is 4, right? I'm sorry, here this is 4, right? My c is 4. So it's 16 minus 16, that's 0. So it's plus or minus square root of 0, right? Over 2, right? So it's actually negative 4 over 2, which is equal to, of course, to negative 2, right? So negative 2, that's my second. So this negative 2 here, that's my second solution, right? That's my second root, right? So I have actually 2 solutions. I was expecting 3 solutions, right? But the thing is, so you see, guys, because of this here, of this 0, I mean, here we had plus or minus. So we are supposed to end up with 2 solutions. But because of the 0 here, all right, I got only 1 solution, right? Anyway, so I have 2 roots. So to answer this first step, so we have, yes, Jesus, yes, absolutely, yeah. Either way, it's okay, yes. So we have 2 solutions, or 2 roots. Let me use the word root instead of solution. So we have 2 roots or zeros. So 2 two roots, right? We have x equal to 0 and x equal to -2, right? So those are my roots. Now, okay, so you see, guys, how it works. You factor, it's equal to 0. Then one of the terms or one of the numbers is 0, and then you solve again your equation, etc., etc., right? So I got the roots. Now what about the multiplicities, right? So to find the multiplicities, we said we have to factor. You see here, so we said we have to factor f of x to find the multiplicities, right? That's our second step. So step 2, we have to factor step 2, so we have, so we have to factor f of x, right? So we said f of x was, was this x cubed plus 4x squared plus 4x, right? So we started, the factorization here, right? We said x is a common factor, so we can factor out x, right? So so we had our x, a common factor. So we said it's x times x squared plus 4x plus 4, right? So that's my x here. This is my first factor. This is my first factor. Now, we have this x squared plus 4x plus 4, right? This is supposed to be, so that's my second factor. Then I have to factor this, right? So we have to factor this. Okay. So how do we factor x squared plus 4x plus 4? Okay. Well, the idea is very simple, guys. So what we do is,
wouldn't it be just x plus 2?
Yeah, that would be x plus 2 square.
Yeah.
Yeah. But yes, absolutely. But the thing is, so this is, here's my x times. So the idea is, because it's a square here, right? So we are supposed to have two solutions, right? If you want to solve x squared plus 4x plus 4 equal to 0, right? So you are supposed to have two solutions. And when you factor, the factorization is always of the form, it's x minus the first solution, okay, times x minus the second solution. Right. Again, I have first solution, second solution, because I have this square. Right. So, however, we said we have only one solution, which is -2, right? Which is this -2, right? So it's going to be x minus -2 times x minus -2. So this is, so here's my x times, and then we're going to have x minus -2 times x minus -2. Right? So this is actually, so it's x times plus 2 times x plus 2. Right? So you see, it's, of course, it's x times x plus 2 square, right? So once you factor, now I can find my the multiplicities, right? So, well, first, so we want to find the multiplicity of x equal to 0. So we want to find the multiplicities, right? Multiplicities. Okay, so what's the multiplicity of x equal to 0? So the multiplicity of x of x equal to 0 is the power of x minus 0. So x minus 0, of course, is just x, right? So what I'm asking here, what I'm looking for here is the power of x. So x here it's actually power 1, right? This is power 1 here. So the multiplicity of x equal to 0 is actually equal to 1 because we have x power 1, right? So so that's the multiplicity of x equal to 0. Right? Now, what about the multiplicity of my second solution or my second root? My second solution, we said it's x equal to -2, right? -2 is my second solution or my second root, right? So the multiplicity of x equal to -2 is the power. So the multiplicity of x equal to -2 is the power of x minus. So this is very important. It's minus here, right? This is x minus 0. This is x minus -2. And of course, x minus -2, that would be x plus 2, right? So what's the power of x plus 2 here? Well, it's 2, right? It's x plus 2 to the power to the exponent 2, right? So that's the multiplicity of x equal to -2. So that's the multiplicity. So so find the answer to answer the question now. So we have two roots, right? So we have two roots. First root is x equal to 0, and it's of multiplicity 1, right? We said it's because we have x power 1, right? So it's of multiplicity 1, right? Because the power of x is 1, or exponent of x is 1. Now, the second root is -2, and it's actually of multiplicity 2, right? Because it's x plus 2 to the power 2. So it's of multiplicity 2. Okay, so you see, guys, how we find the multiplicity. So you have to factor. Once you factor, then the multiplicity would be the power of x minus your solution. So for example, if I have my solution is -2, then I have to look for the power of x minus -2. So that would be x plus 2, right? So here I have x plus 2 squared. So the multiplicity is 2, right? Any question, guys? Let me see in the chat if there's any. Okay, cool. Right, so that's yeah. Okay, so that's that's our first example today. Again, guys, please feel free to interrupt me if you have any question. Right? Okay, so let's do another example. Right? So let's see. Next example. Example number 2. Number 2. Right, so let's say my f of x is -2 x power 5, right, plus 5 x to the power 4, and minus, not plus, minus, minus 3 x cubed, right? So again, the question is to find the roots and their multiplicities. Right? So we said step 1, we want to find the roots, right? So step 1, we said you have to solve f of x equal to 0. So step 1, here's my step 1. So here's my step 1. So we have to solve. So we want to find the roots. Find the roots. Right? So we have to solve f of x equal to 0. Right? So we have to solve negative 2x to the power 5 plus 5x fourth minus 3x cubed, right, equal to 0. All right, so, well, so here you see, guys, here it's the degree is 5, right? So we expect to have 5 solutions, right? So we expect, because that's the highest power of x, so we expect 5 solutions. Okay. So, of course, we cannot use the quadratic formula because it's obviously it's a power 5, it's not power 2. So, of course, then the next thing we can try to do is try to factor, right? So we can factor, try to factor. So factor, right? And a common factor would be, of course, well, here we have x, a common factor, but we can do better than x, right? We can have even x cubed as a common factor, right? You know, here x power 5, x power 4, x power 3. So x cubed actually would be a common factor. So x cubed, a common factor. All right, so I can factor out this x cubed. So let's factor out x cubed. So that would be x cubed here. X cubed times, and then of course, so here, if you pull out x cubed, then you are left with x squared, right? You subtract 3 from 5, you are left with square, right? So it's you are left with negative 2 times x squared. So this is here negative 2 times x squared plus, there's a plus here, there's a 5 here, so here's my 5. Here, this is power 4, so you will subtract 3, so you are left with 1, so it's power 5x, or 5x to the power 1. And finally, of course, if you pull out this x cubed, you are left with this negative 3, right? So it's minus 3 here, equal to 0. Right? So again, it's the same idea, right? We have now a product which is equal to 0, right? This is equal to 0. So again, guys, it has to be equal to 0. Otherwise, if it's equal to 1, for example, you cannot say your x cubed is equal to 1 or wherever, right? It has to be equal to 0. So because it's equal to 0, then you can say, well, my first term here is 0, or my first number is 0, and my second term or second number is also 0. Okay, so either one is 0. So it's so either the x cubed is 0, or the negative 2 x squared plus 5x minus 3 is 0, right? So I have 2 equations to solve, right? X cubed equal to 0. But I mean, x cubed equal to 0 if you apply the third root. So third root here and third root here. Then your x would be equal to the third root of 0. But I mean, 0 times 0 times 0 is 0. So third root of 0 is just 0, right? So my x is equal to 0. So that's my first solution, or my first root, right? Now, what about the second equation? Well, again, second equation is just a quadratic. It's a quadratic equation, right? The highest power of x is 2, which is a good news because I can use my quadratic formula, right? So here, this is power 2. So we can use our quadratic formula. So then your x would be minus b, so minus 5 plus or minus square root of b squared, that's 25, minus 4 times A times C over 2A. All right, so then X, it's -5 plus or minus. So 4 times 2, that's 8 times 3, that's 24. That would be 25 minus 24, which is square root of 1. So it's plus or minus square root of 1 over -4, right? So be careful, guys. Here, you have to finish the operation on the top, right? You cannot make any cancellation here. First, you finish the operation on the top, right? So it's, it's -5 plus or minus 1 over -4. So actually, we're going to have two different solutions here. So first, my X would be -5 plus 1 over -4. So that's -4 over -4. So that would be +1. Or X is -5 minus 1 over -4. So that's -6 over -4. So that's negative over negative. Of course, that would be positive. And you can reduce your fraction. You have to reduce your fraction, right? I mean, 6 and 4, both are divisible by 2, right? Both are even numbers. So both are divisible by 2. So we can divide both by 2. And so 6 over 2, that would be 3. And 4 over 2, that would be 2. Okay, so it's 3 halves, right? 3 over 2. So yes, so my solutions, I got, so I got 0, I got 1 here, and I got 3 halves. Okay, so the roots are X equal to 0, X equal to 1, and X equal to 3 halves. All right. Now, so that's the roots. Now, what about the multiplicities, right? Okay, so that's our step number 2. So step number 2, you want to find the multiplicities, right? So we have to find the multiplicities. So we have to factor f of x. Okay, so we have to factor f of x. So let me just remind you. So f of x was -2, x to the power 5, plus 5, x to the power 4, and then minus 3, x cubed. Right? So we said, so we started actually the factorization, right? We said x cubed would be a common factor, right? So first common factor, common factor is x cubed. So here we're gonna have, of course, -2x squared, right? X cubed times -2x squared, that will be this -2x to the power 5. Then there's a plus here, 5x to the power 1, so it's x, minus, there's a minus 3, and you pull out the x cubed, so you are left with this 3 here, right? So that's my f of x. So I got my first factor here, this one here. This is my first factor, right? Now I have to factor this minus 2x squared plus 5x plus 5x minus 3. Okay, so we have to factor this. We have to try to factor this quadratic function minus 2x squared plus 5x minus 3, right? So what will be the factorization of this minus 2x squared plus 5x minus 3? Well, so the idea, guys, again, is just to, so here is my x cubed. So as I said, here, this is a square, right? So we expect to have 2 solutions. And let's say you have your 2 solutions. So then when you factor, you're going to have something of the form x minus the first solution right, times x minus the second solution, right? So again, guys, I'm trying to factor this thing here, right? And as I said, because it's a square, we expect to have two solutions. So here's my two solutions, x minus the first solution times x minus the second solution, right? But there is just one thing here. We need to be careful because, you know, guys, this is here, there's this negative 2x squared, right? And here, if you multiply x by x, that will be x squared, not negative 2x squared. So actually, we need to put this negative 2 in the front here. It's negative 2 here. All right. So what I'm saying, guys, is that we're gonna have x cubed times this negative 2, right? This one here, then times x minus my first solution. My first solution was, remember when we solved this x squared minus this minus or negative 2x squared plus 5x minus 3, we got we got 1 and 3 halves, right? So my first solution is 1 and my second solution is the 3 halves, right? So so it's x minus 1 here times x minus the second solution, which is 3 halves. So here's my 3 halves. So that would be the factorization of, actually, so you can even, you can move the negative 2 to the front. So it's actually, negative 2 times the x cubed times this x minus 1 times the x minus the 3 halves. Right? And okay, so now I can try to find my multiplicities, right? So first, so we said we had the roots are x equal to 0, x equal to 1, and x equal to 3 halves. So let's start with x equal to 0. So I want to find the multiplicities of multiplicity of x equal to 0. So by definition, we said the multiplicity of x equal to 0 is the power of, so the multiplicity of x equal to 0 is the power or the exponent power of x minus 0. Power of x minus 0. And of course, x minus 0, that would be just x. So what's the power of x here in the factorization? Well, x has power 3, right? So that will be the multiplicity of 0. Right? So, so the multiplicity here of 0 is actually 3. Now, what's the multiplicity of the next root? So the next root is, we said it's 1, right? We have 0, 1, and 3 halves. So the multiplicity of x equal to 1 is the power of x minus 1. Right? So the multiplicity of x equal to 1 is the power of x minus 1, which is of course x minus 1, right? Okay, so well, what's the power of x minus 1? Well, we have just x minus 1 to the power 1. This is, so here, this is supposed to be power 1 here, right? This is power 1. So then that will be the multiplicity of x equal to 1, right? And last root is the 3 halves, right? So the multiplicity of 3 halves is the power of x minus 3/2. Right? So what's the power of x minus 3/2? Well, it's just power 1 here. Right? So, okay, so now I can answer the question. So here's the final answer. So we have the following roots. So x equal to 0, which is of multiplicity, we said 3, right? That's the power of x minus 0, or power of x of multiplicity equal 3. Then next we have next root is x equal to 1, and we said the multiplicity of x minus 1, x equal to 1 is the power of x minus 1, so it's 1. So it's of multiplicity 1. Right? And finally, the 3/2, the last solution is 3/2, and that's of multiplicity. So that will be the power of x minus 3/2 in the factorization, and it's just 1 again, right? It's just right here, right? It's power 1, so it's of multiplicity 1. Okay. So you see, guys, what do I mean by multiplicity? So you have to factor. You see how I factored this, my function f. So you have to factor your function f. Once you are done with the factorization, then you have to check. So the multiplicity of a solution, that will be the power of x minus that solution in the factorization, right? So that's what I mean by the multiplicity. Any question, guys, about this example? All right, so here's an exercise. Okay, exercise. So we need to find exercise. So we need to find the roots and the multiplicities. Find the roots. So please follow the same steps, right? First, solve. Second, factor. So find the roots and multiplicities of, right, so let's see. Number 1, so let's say f of x is 2x power 4 minus 6x cubed and plus 4 x squared. Right? Number 2, so f of x is x cubed minus 4x squared minus x plus 4. All right. Okay, guys. So we have 5-10 minutes to find the roots and multiplicities of these functions f of x. Please let me know, guys, if you have any question. Right. So any guess for number one? What will be the roots and the multiplicities of the first function? So any guess for number one, guys? The roots? All right. So for number one, okay, probably I'm gonna move to the next page. Okay. So for number one, so we have we have f of x, which is 2x power 4 minus 6x cubed, right, plus 4x squared, right? So first we said we have to find the roots. So step one. So we have to find the roots, right? So we have to solve f of x equal to 0. So we have to solve 2x fourth minus 6x cubed plus 4x squared equal to 0, right? So of course, as I said, this is power 4. I mean, the degree is 4. Highest power of x is 4, so we expect to have 4 solutions. But anyway, so let's see. We cannot use the quadratic formula, of course. So we can try to find like a common factor. So here there's an x in here, there's an x in here. So x is a common factor, and actually we can do even better than x. We can factor out x squared because there is an x squared in here, there's an x squared in here, and there's an x squared in here, right? And also you see here, this is 2, this is 6, this is 4. I mean, all of them are even numbers that are divisible by 2. Okay, so we can, a common factor would be 2x squared, right? So a common factor is 2x squared, right? Again, because you see here's 2, 6, and 4. They are all divisible by 2, so we can factor out 2, right? So common factor is 2x squared, so factor out 2x squared times, so here's 2, then x power 4, so you subtract power 2 from power 4, that will be 2, so it's just x squared here. There's a minus, so minus, this is 6, so if you pull out 2, then you are left with 3, right? 2 times 3, that will be this 6 here. Then there's an x cube, right? You pull out x squared, you take the difference, so the difference between 3 and 2 is 1, so it's x power 1. And then plus, there's a plus, 4, factor out 2, so that would be 2 left here, 2 times 2, that would be 4. And you factor out x squared, right? So it's just plus 2 here, equal to 0. All right, so once you have a product, then equal to 0, then either the first factor is 0 or the second factor is 0. So either the 2x squared is 0 or the x squared minus 3x plus 2 is 0. All right, so now 2x squared is 0. You can divide by 2. I mean, here's by 2. This is by 2. And 0 over 2 is still 0. 0 over any non-zero number is 0. So my x squared is just 0. And then, of course, you can apply square root. Here's my square root. And so my x would be square root of 0, which is 0. So I got my first solution. So my first solution is just 0. Now, what about the second factor, the x squared minus 3x plus 2 equals to 0? Well, that's a quadratic equation, right? So we can use a quadratic formula. So then your x, it's minus b. So it's minus negative 3 plus or minus square root of b squared negative 3 squared, that would be 9, minus 4 times a is 1, times c is 2, over 2a. right? So then your x minus -3, that would be +3, plus or minus square root of, so 9 minus 8 is 1. So square root of 1 is 1, so it's plus or minus 1, right? Over, of course, over 2. Okay, so then we have two solutions. So x is equal to 3 plus 1 over 2. That will be 4 over 2, so that will be equal to 2. Or, of course, x is 3 minus 1 over 2. That will be 2 over 2, and that will be 1. So we got two solutions, two different solutions, right? It's 2 and 1. So in total, we got 3 solutions. Here's my 0. I got 2 here, and I got 1, right? Right, so those are my roots. Now I want to find the multiplicities, right? So that will be my second step. So step number 2. Step number 2. So I want to find the multiplicities. All right, so we have to factor f of x. So we have to factor f of x. So f of x, again, it's 2x fourth minus 6x cubed plus 4x squared. All right. We said a common factor would be 2x squared, right? So we can pull out, we can factor out 2x squared. So here's my 2x squared times here, that will be x squared minus 3x, and then plus 2, right? So I got my first factor here, and now I have to factor this. All right, so we said, well, this is a square, so we expect to have two solutions. So it should be x minus first solution, right? And then times x minus the second solution, right? And of course, in front, I have here, I have this 2x squared, right? And again, here, you see, you know, guys, this is just x squared. It's 1x squared, right? So, I mean, here's x, here's an x. I mean, x times x, that will be the 1x squared. So I mean, if I had a different number than 1, for example, if I had 4, let's say I had 4 here, then I have to put 4 here, all right? Or if I had 5, I have to put 5 here. But it's just 1 there. I mean, it's 1x squared, so it's just 1 there. So, you know, so this is just 1 here. All right. Now, so what's my first solution? Well, it's you know, so it's 2x squared times x. My first solution, we said here, we said it's 2, and then I got 1, right? So 2 and 1, so it's x minus 2, and then times x minus 1. So again, those 2 and 1 are the solutions of this x squared minus 3x plus 2. All right. So yeah, so I got my factorization. Now I can find my the multiplicities, right? So what will be the multiplicity of? So we have 3 roots, right? We have 0, right? We have 0, then we have 2, and then we have 1. So multiplicity of 0, that's the power of x minus 0. So answer. So we have the following roots. First, I have 0, and that's of multiplicity. Well, it's a multiplicity 2 because, well, that's the power of, it's a multiplicity 2 because that's the power of x minus 0. It's the power of x minus 0. Now, next root is 2, and that's of multiplicity. So what's the power of x minus 2? That's multiplicity 1, because you see here, this is its power 1 here. So it's of multiplicity 1 because that's a power of x minus 2. Power of x minus 2. And finally, last root is 1. And it's also of multiplicity 1, right? Because the power of x minus 1 is 1. Multiplicity 1. And that's the power of x minus 1. All right. Any question, guys? So to find the roots, multiplicities, first solve. All right. And then you factor. So you have to factor completely the, your function after. So that's for the first function. The second function, it's so for number 2. So we have f of x. I think it's what was f of x? Yes, it's x cubed minus 4x squared minus x plus 4. Right. So first we have to solve step 1. I want to find the roots. So solve f of x equal to 0. Right. So we have to solve x cubed minus 4x minus x plus 4 equal to 0. It's not, so we have, this is power 3, the highest power here, the degree is 3, so we expect to have 3 solutions. So we expect 3 solutions. Okay. Now, you cannot use quadratic formula, it's a cube, so we need to factor. So if you take a look to the terms here, well, x is not the common factor, so we cannot really factor out x because there's no x here in 4. So if you cannot factor, so we can, what we can try is to, so we cannot factor here. So we can try partial factoring, right? So try partial factoring. So what do I mean by partial factoring? Well, you can take, for example, let's say the first 2 terms here, these 2 here, all right, and the last 2 terms here, the minus x plus 4. So you can try to factor the x cubed minus 4x squared. Well, obviously x cubed minus 4x squared, I mean, x is a common factor, and even better than x, we have x squared is a common factor. So in the first, for x cubed minus 4x squared, we can factor out x squared, right? So here, here and here, the common factor would be x squared. So let's factor out x squared. So here's my x squared times x squared times x, that will be x cubed. There's this minus, so here's my minus. Pull out this x squared, so we are left with 4. So minus 4 here, right? So that will be the factorization of the first 2 terms, right? That's what I call partial factoring. Now I can try to factor the last 2 terms here, minus x plus 4. Well, minus x plus 4, I mean, there's no common factor, right? It's, I mean, minus x plus 4, x is not a common factor, 4, it's not a common factor, so I'm gonna just leave it minus x plus 4. So minus x plus 4. However, you can, minus x plus 4, you can write it like, if you use a parenthesis, you can write it like minus parenthesis x minus 4. Right, because you see guys, minus x, and then minus minus, that will be a plus. That will be this plus here, right? So what actually, so I, if you distribute the sign, you're gonna have a plus 4, right? Minus minus, that will be plus 4. But then you see, you're gonna have a common factor here, which is x minus 4, right? Here's my x minus 4 here, x minus 4 here. So I can factor out this x minus 4. Right, so we're gonna have x minus 4 times, well, here there's x squared left, so here's my x squared, and then there's a minus, it's minus here, so here's my minus, and then just be careful here, guys. I mean, if you pull out this or factor out this x minus 4, you are left with actually with 1, not 0, because this is like 1 times, this is like 1 times x minus 4. So if you pull out the x minus 4, you are left with this 1 here. Okay, so it's actually x squared minus 1. Right? Equal to 0. Okay, so here's my factorization. So it's x minus 4 times x squared minus 1. Now, I want to solve, right? So x minus 4 times x squared minus 1 equal to 0. Then, again, it's a product. This is a product which is equal to 0. So if you have a product equal to 0, then yes, then you can say this one here is 0 or this one here is 0. So either x minus 4 is 0 or the x squared minus 1 is 0. Right? So x minus 4 is 0, then x is going to be equal to 4. X squared minus 1 is 0, then x squared would be, of course, here's plus 1 here, then x squared would be positive 1. You apply square root, there's a square root, there's a square root, and because the power here is even, this is even, right? Then you're gonna need the plus or minus. So, so then x is plus 1 or x is negative 1 or x is negative 1. So I got, as expected, I got actually 3 solutions. So I have my positive 4, I have my positive 1, and I have my negative 1, right? I got 3 solutions. So those are my roots. Okay. So for this first step, so the roots are x equal to 4, positive 1, and negative 1. Okay. Now, last step, step 2, that will be, so we need to find the multiplicities. Multiplicities of the roots. All right, so now we have to factor completely f of x, right? We have to factor f of x, right? So we said, so we had f of x. F of x was this, again, we had, what was f of x? So it was x cubed, right, minus 4x squared, right, minus x plus 4, right? So then we have this partial factoring, right? We got this, we got this x minus 4 times x squared minus 1. So we got, so this is equal to x minus 4 after partial factoring, right? This is from the step 1. So we got x minus 4 times x squared minus 1. But this is not a complete factorization of f of x, right? Because you can still factor this one here, the x squared minus 1, because we have a square here, right? So we can try to factor the second one here. So this is not a complete factorization, right? So we have to continue with with the factorization. So we have to factor this one here. I got, this is my first factor. It's a factor because here you have x power 1, right? So you cannot really, so you're gonna stop there, and you cannot factor this x minus 4. That will be actually my first factor. But for x squared minus 1, because you have the square, then you can try to factor this x squared minus 1. Now, so I got my x minus 4. Now, what would be the factorization of this x squared minus 1? So remember, guys, we said it's a square, right? This is a square. So we expect to have 2 solutions. And when you factor, it's going to be of the form x minus first solution, right, times x minus the second solution. All right. And I got actually 2 different solutions, right? I got +1 and I got -1, right? When I solved, you see here, when I solved x squared minus 1 equal to 0, I got +1 and -1. So my first solution is +1. So this is actually x minus 4 times x minus first solution, it's 1, times x minus second solution, which is -1. All right. So I mean, this is of the form x minus 4, x minus 1, and times x plus 1. All right. So now I can. So this is the complete factorization of my f of x, right? This is a complete factorization of f of x. Okay. Now I can find my my multiplicities, right? But if you check the powers here, guys, all the powers are just 1, right? This is power 1 here. This is power 1. This is power 1, right? So all the roots, they have the same multiplicity, which is 1, right? So final answer would be, so we have the following roots. So first solution, we said it's 4. So x is equal to 4. Remember, guys, we said the roots are, you see here, we said the roots are x equal to 4, x equal to +1, and x equal to -1. So the roots are x equal to 4, and it's of multiplicity 1. That's because that's the power of x minus 4. Now, x equal to 1 is of multiplicity 1 because that's the power of x minus 1. And x equal to -1 is of multiplicity 1 because that's the power of x minus -1 minus my root, my -1, right? So which is, of course, x minus -1. That will be the x plus 1. All right. Any question, guys? Anyway, so yeah, so that's for the roots and the multiplicity. All right. So now you may ask why we are doing this multiplicity thing. Well, it's because of the following observations. So so we have the following observation. So that would help with the graphing of polynomials. So we have the following observation. Okay, so if a root, or if the multiplicity of the root if the multiplicity of a root is even, okay, then actually the graph of f of x, well, is going to touch the x-axis and turn around. Okay, so what do I mean by turning around? So so we're going to have the following situation. So here's my graph. So a root, that's, again, root is just another word for x-intercept. X-intercept, that's intersection of my of the graph of the x-axis. So suppose this is my root. All right. So the graph of f of x, if the root is even, all right, if the root is even, then the graph of f of x is going to touch the root, all right, and then so it won't cross the x-axis, so it's going to turn around here. Okay, so that's my f of x. Okay, because this root is of even multiplicity. Now, if the multiplicity of the root is odd, then the graph is going to cross the x-axis. All right. So if the multiplicity of the root multiplicity of root is odd, okay, so here it's odd, then the graph of f of x crosses, is going to cross the x-axis, right? So we're going to have the following situation. So here's my graph, my graph. Again, when we say root, it's x-intercept. It's so it's on the x-axis. So we have this root here, and so what the graph is going to do now, because the multiplicity is odd, so the graph is going to cross the x-axis. Okay. So here's my f of x. So the graph is going to cross the x-axis, right? Again, this is because this root here, the multiplicity of this root is odd. Odd multiplicity. All right. So you see why this is useful, guys, the multiplicity, right? It's going to help us with the graphing the polynomials, all right? Any question? Nope. Okay, perfect. So now we can we can try to graph polynomials. So now I guess we have all we need to graph our polynomials. So probably I'm gonna move to the next page. So now we're gonna graph. Oops. So now we're gonna graph polynomials.
Sir.
Yes.
Please, can I see the page?
Oh yeah, sure.
For a second.
Second one here.
The last part.
Last part. Sorry, it's a mess now. How to come back to this? Oh yes, here. Okay, here's Zoom. Better. The last part, right?
Yeah.
Okay.
The very last part.
Mm-hmm.
Yes. I'm good.
Okay, perfect. Thank you. Yeah. So now we're gonna graph our polynomials. Okay, so the steps are the following, guys. So to graph polynomials, first you need to find the roots, the x-intercepts, the roots, and their multiplicities, of course. Right. Second thing to do is, of course, to determine the behavior at infinity. Right. So we said, so we have to determine. So we're gonna use our table. Remember, so determine the behavior at infinity. All right, at infinity. Okay, and another thing you can do is find the y-intercept. Find the y-intercept. All right, that's f of 0. Okay, so we're gonna use all these informations, right, to sketch the graph of f of x. Okay, so we're gonna use those informations to sketch the graph, to graph f of x, right? So, okay, so we have 10 minutes, I guess. That would be just, I mean, 10 minutes, that'll be probably enough for one example. So again, I'm gonna do one example, right? And then next time, guys, I'm gonna give you probably an exercise where we have to graph polynomials, right? So let me do one example at least, all right? So example, right? So let's say f of x is, let's take a nice example. So let's take, let's say f of x is x to the power 4 minus 6x cubed plus 9x squared. Okay, so that's my function f. So of course, this is a polynomial. All the powers are all the powers are positive whole numbers. So it's a polynomial. So f of x is a polynomial, of course, is a polynomial. Right. So what's the degree of f? What's the highest power of f here, of x here? It's 4, right? So degree is 4. And what's the leading coefficient? Well, it's times 1 here. So the leading coefficient is 1, right? So anyway, so this f of x is a polynomial of degree 4. Degree 4 and leading coefficient 1. Anyway, so first thing to do, guys, we said we need to find the x and the roots and their multiplicities, right? So step one, first thing to do, find the roots or the x-intercepts and their multiplicities, right? That's the first thing to do. Okay, so well, first we have to solve. We want to find the roots, right? So we to find the roots. We said and their multiplicities, right? So first, step 1 would be to solve f of x equal to 0. So we want to find the roots first. Find the roots. So we have to solve f of x equal to 0. X equal to 0. So we have to solve this x fourth minus 6x cubed plus 9x squared equal to 0. Right? So this is a power 4. We cannot use a quadratic formula, so we have to factor. So a common factor, of course, would be, you can see here, a common factor is x. And better than x, we can even factor out x squared. So let's factor out x squared, right, times, and then x squared times x squared, that will be this x to the power 4. There's minus, here's my minus, there's a 6, x cubed, pull out x squared, then you're left with x, and plus 9, right, equal to 0. So I got my product equal to 0, so then I can say, well, either x squared is 0, or this x squared minus 6 plus 9 is 0. Right, so now x squared is 0. You can apply square root, plus or minus because the power is even. But here it doesn't matter because square root of 0 is 0 and plus or minus 0 is just 0. So my x is just 0. Right, now for the second equation, it's a quadratic equation, right? You can use a quadratic formula. So then your x would be minus b. So it's minus negative 6 plus or minus square root of negative 6 squared, that would be 36, minus 4 times 8 times 1 times 9. So that's 4 times 9, that's 36. So we're going to have 36 minus 36. So actually it's plus or minus square root of 0 over 2a over 2 times 1. Right? So actually your x, we're going to have just one solution here. So minus negative 6, that's positive 6 over 2. So x is 3. So here I got, well, first I got 0 and I got 3. Right? So we have two roots, 0 and 3, right? So two roots. X equal to 0 and x equal to 3. Right? Now, so that's the roots. Now, what about their multiplicities, right? So step 2, we have to find the multiplicities, right? So we have to factor completely f of x, right? So we have to factor, so find the multiplicities, right? So we have to factor completely f of x, right? So my f of x, so it's, my f of x was this x fourth minus 6x cubed plus 9x squared. We started the factorization, right? We said x squared is a common factor. So we have here, you see here, guys, x squared times x squared minus 6x plus 9, right? Now, how do you factor? So we need the complete factorization of this, right? So we have to finish the factorization here. I mean, we are done here with the x squared. That's my first factor. But then we have to factor this, the x squared minus 6 plus 9, right? And so I got my, here's my x squared. Now, again, guys, this is, it's a square here. So we are supposed to have two solutions. So when you factor, a complete factorization would be of the form x minus a first solution, because I have two, right? This is a square here, times x minus the second solution, right? But you know, when we solved x squared minus 6 plus 9 equal to 0, I got only one solution, right? So it's actually, it's a double solution. It's a 2 times solution to 3, right? It's, so I got only 3 as a solution, right? This is a 2 times solution, right? So this is, so here it's x squared times x minus first solution was 3 times x minus, well, second solution is also 3 because I got only one solution, right? So it's again 3, right? So that's actually x squared times x minus 3 squared. Right? So that would be my factorization. So that's the complete factorization of f of x. Now, the multiplicities. Well, so now I can answer. So this. So we have, so first root, following roots, right? So first root is 0. So what's the multiplicity of 0? Is of multiplicity. So what's the power of x minus 0? Right? Again, guys, we got, you see here, I got, we said we got two roots, x equal to 0 and x equal to 3. So the multiplicity of 0 is 2 because the power of x minus 0 is 2. Is of multiplicity 2. That's the power of x minus 0. And second solution or second root was 3, and that's of multiplicity 2, right? Because you see here, it's power 2, so it's of multiplicity 2. Okay, that's the power of x minus 3. Okay. Right, so I got my roots, I got my multiplicities. We said the second thing to do is, second step would be to determine the behavior at infinity, right? Here. Determine the behavior at infinity. So what's the behavior of at infinity here? So we said, so the degree of this f of x is 4, which is even, and the leading coefficient is 1, which is positive, right? So, so this is, so step 2 here, the behavior at infinity. Right? Well, it's f of x is, you know, it's x fourth minus 6x cubed plus 9x squared, right? So the degree is even. Degree n is 4, is even. And the leading coefficient, a subscript n, is 1, right? This is 1 times x to the power 4. So it's 1, which is positive, right? This is positive. So remember, in our table, when we have even degree and positive leading coefficient, so if you check the table, guys, so then the behavior at infinity would be this one here, this here. All right. So again, this is the case when, so this is when degree n is even, degree is even, and positive when you have positive leading coefficient, right? I have 1 more minute, guys. Let's. Oh no, I went over time actually. No. So yeah, okay. It's just one. Please give me 1 minute, guys, and I'm done. So just this last step is to find the y-intercept. Y-intercept. So y-intercept is just f of 0. Okay, y-intercept. We have to find f of 0. Which is 0 to the power 4 minus 6 times 0 cubed plus 9 times 0 squared. So everything is 0, so it's just 0. So the y-intercept is just 0. Y-intercept is just 0. All right. So now, how do I use this? All these informations. So it's the graph. So how do I use all these informations to graph f of x? Well, and I will do more examples next time, guys. All right. So I have the roots or the x-intercepts. We have 0, right? That's my first root. The second root was 3, right? The behavior at infinity, we said is gonna be here, and my graph is gonna be here at positive infinity, right? And then we said this is multiplicity is even here, and this one is also of even multiplicity, right? So, and so I'm gonna join the points. So here I start from up here, and I'm gonna go to this point, but then because the multiplicity is even, I won't cross the x-axis. I'm gonna just turn around, okay? Then the next point here, the same, it's even. The multiplicity is even, so I'm gonna turn around and I'm gonna go up here, right? So that would be the graph of f of x. Anyway, guys, so this is just to give you an idea. We don't have time, but next time I will do more examples. All right. I'm sorry, I went over time as usual. So I'm gonna stop here, and I will see you next Monday. So there will be no homework, no new homework, guys. Yeah, so I will see you on next Monday. Please take care and stay safe. Thank you, guys. I appreciate it. Thank you, everyone. Thank you.
Thank you, Professor.
Thank you. Thank you, everyone.